Hello everyone, I would like to discuss today a model for the Covid-19 virus. So first, it's just of course a simplified model, but just a way of thinking. So for example, if we assume that the number of patients is n as a function of the time, the most simple model of course would correspond to a certain exponential function a to the power of x. I chose the function 1.7 to the power of x, 1.7 because the index in which the disease spreads is about 70%. 70% of people are get sick in contact with other people. This function, of course, and here to the power of t, n of 0 is 1, therefore the function starts, let's say this is the time, this is n of t, and of course this function looks like this and it continues to grow indefinitely. This model of course does not make any sense, at least not after a while, since this tends to infinity. Obviously the number of patients will not tend to infinity. In fact, if you check this value after 20, let's say that the time here is in days, then n of 20 is about 40,642, but that would keep growing and that doesn't make sense. So what changes in reality? If we think about this function, what changes in reality is t. T does not stay constant because each time we have more people who get cured, and that means that after they get cured, they typically do not get infected again, and that means that it's not 70% each time. Therefore, this number decreases as time passes. The question is, how does this number decrease? So a way to decrease it, for example, is to decrease it by a certain percentage. So for example, if this number decreases by 2% every day, that means this number we multiply by 1 minus 2 over 100, but every day, that means to the power of t. This is how we decrease this function, this exponent, by 2% every day. If you graph this function, then it is when t is 0, of course, it passes to the point 0, 1, same as the other one. And the difference is that, for example, this function reaches, it grows until it reaches the standard maximum, and then it decreases. If you check, you can see that this maximum for 2%, it happens approximately after 49.5 days, and the y value of this is about 15,715. There is this number here, this function is very sensitive to a change in this number. So in reality, this number here is the key to learning the evolution of the virus. If you take the same function only with the 1 minus 3 over 100, the only difference changing the 2 over 100 to 3 over 100, then the function changes dramatically, and of course again it starts, it's 0, 1, and it has a certain maximum and it decreases again to 0, but this maximum happens after 32.8, which is not such a big change, but the maximum, the number of patients, if you want to, is approximately 607. That is a very big change. So as you can see, the key in order to study the evolution of the virus is to determine this number, which changes the evolution of the function dramatically. This, of course, is a very simplified model, but it's one way of looking at the evolution of the COVID-19.